So tell me, Bhumika, Arnav, or Sahas, what we learned in a previous session. Maybe 3 weeks back, you learned something related to Newton's laws of motion. So as it is a very long gap, maybe I have to recall them, and you have to again recollect them, and after that we'll start today's session. Okay, Arnav, can you hear me?
Yes, sir.
Right. Maybe you are absent in last session. Whether you attended
Sir, I attended the previous physics session.
last physics session, you attended Newton's laws of motion.
No, sir.
Okay. So maybe you attended 1 or 2 sessions. How many sessions you attended?
Sir, that one which was on Sunday, I didn't attend that. Otherwise, I attended everything.
Okay, right. So Sahas, have you attended the last session? This is actually fourth session of Newton's laws of motion. And have you attended the third session? Sahas, have you attended third session? Right. So who attended then? Bhumika. Bhumika is there anyway. She is there, and Arno maybe missed. I don't know. I too not remembered. Why? Because it is very long days back. Okay. So we have to recollect them, what we learned in a previous session. So little bit introduction related to that. And before going to start about them, what is your chapter, Arnav? Which chapter we are learning? Which chapter we are learning, Arnav?
Sir, Newton's laws of motion.
Very good. Newton's laws of motion. And can you say briefly about Newton's laws of motion? What we are learning in that particular Newton's laws of motion?
Sir, Newton gave different laws in motion.
Right. So to understand about motion and how a motion of an object will change with the force, that is explained by a scientist called Newton, and he gave 3 laws to understand them, and we are learning about them. And maybe you know that in first session you learned about force, and maybe you learned about Newton's first law of motion, and in a second session we learned about Newton's second law, and related to that whatever applications are there, those applications we learned. And apart from that, in a third session we learned about Newton's third law. And Bhumika, maybe you are in listening mode only, maybe some network issue is there. Once you message me whether you are listening or not, am I audible to you or not? Right. Okay. So can you say first law of motion, Arnav? First law of motion. What is first law of motion? Arnav, are you there?
Yes, sir.
Right. Tell me. What do you mean by, sorry, what is first law of Newton? Or Newton's first law of motion? Can you
Sir, a
say?
body remains in state of rest or motion
Okay, good. Continue.
unless an external unbalanced force acts on it.
Very good. Until unless an external force is applied on a body, the body which is in a state of rest or the body which is in a state of uniform motion will be in a same state. So that is about first law. And what is the importance of a Newton's first law? What is the
Sir,
importance of
it
a
gives
Newton's first law?
inertia.
Right. That Newton's first law can explain or can give definition related to force and inertia. Both can be explained. Right. Can give definition related to force and inertia. Both can be explained. Right. And apart from that, second law. Have you attended that session or no? Second law. Do you know about it?
Yes, sir.
Right. Tell me, what is Newton's second law of motion? Sahas and Bhumika, you can type your messages if you are unable to speak. Sahas, can you speak?
Yes, sir. He spoke in the previous class.
Right.
Sir, can you hear me?
Sahas,
Yes, sir.
right. Can you say about Newton's second law of motion?
Sir, I think I wasn't there for that class.
You are not there in that class?
No, sir.
Okay. And Arnav, tell me. Newton's second law of motion.
So that force is equal to rate of change of momentum.
Right. Generally, the external force applied on an object will be directly proportional to the rate of change of momentum of that object. and it will be in a same direction. What will be in a same direction? Force and rate of change of momentum both will be in a same direction. So that is about Newton's second law of motion. And what is the importance of a Newton's second law of motion? Bhumika, good. Tell me what is the importance of a Newton's second law of motion? Newton's second law of motion.
So maybe momentum.
Importance. Okay. Right. So momentum generally is explained in that particular Newton's second law of motion, but you have to say like this: the magnitude of the force can be known in second law. Definition will be known in first law. Magnitude will be known in a second law. And the third law. Can anybody say Newton's third law, which is very, very easy? Sahas, tell me what is Newton's third law of motion? Newton's
Uh,
third law of motion.
Sir, I think something like every action has an equal and opposite reaction.
Very good. Every action will have an equal and opposite reaction. Very good. So action will be equal to minus reaction. That will be Newton's third law of motion. And based on that only, many examples we discussed in that class. Maybe you know about a best example, and that best example is nothing but motion of a rocket. When rocket is moving up, gases will escape, and whatever gases are releasing, if it is action moving of rocket upward, that will be reaction. So action and reaction, and what will be the nature of action and reaction, and how to understand them, those things we learned in a previous session. So that means Newton's third law we learned. And can anybody say what is the importance of a Newton's third law? First law gives definition related to the force. Second law gives magnitude of the force. And what about third law? What it will tell us? What is the importance of it? What is the importance of a Newton's third law of motion?
So that force acts on two different bodies.
That is generally when I ask you action and reaction, whether act on a same object or different object, then you have to give this answer. But I'm asking, what is the importance of a Newton's third law of motion? Importance I am asking. So like that you said just now, what you said, first law gives a definition related to the force. Second law gives magnitude of the force. And what third law will tell us? What third law will tell us? Right, Bhumika. Okay. Law of conservation of momentum. Okay. Whether I said about the law of conservation of momentum on that day? No. I have not explained about law of conservation of momentum, even though it is an application of Newton's third law. But what is the importance of a Newton's third law is nothing but we can understand the nature of the force by third law. So definition will be given by first law, magnitude will be given by second law, nature will be given by third law. So all will discuss about force only, and with the force how motion of an object will change. So that will be discussed in a Newton's laws of motion. So three laws are there, and those three laws are very important, and among them the third law is very important. And the third law is nothing but what? For an every action there will be an equal and opposite reaction. Okay, so let us try to understand about applications of a Newton's third law. And to understand about applications of a Newton's third law, generally our today's session is application of a Newton's third law, and one of the application we are going to learn, and about that only we are going to understand. But before going to understand about it, let me ask you one small question for you, and that question is related to the law of conservation of energy. Can anybody say what is the law of conservation of energy? Law of conservation of energy. Law of conservation of energy. Arnav, are you there? Arnav?
Yes, sir.
Right, tell me. What do you mean by law of conservation of energy? Do you know about it? Law of
Yes,
conservation
sir.
of energy. Okay, tell me.
So that energy cannot be created nor it could be destroyed. It is
Right.
transferred from one to another.
Very good. Energy neither be created nor be destroyed, but it can change from one form of energy to the another form of energy. That is about conservation of energy. And now we are going to learn about one important topic which is related with the Newton's laws of motion, that too third law, and that is about nothing but conservation of linear momentum. What is about the thing which we are going to learn today? Conservation of linear momentum. And can you say what is a linear momentum?
So that acts in a straight line.
Linear momentum. I am asking about linear momentum. What is a linear momentum? Or what do you mean by momentum? What do you mean by momentum? Tell me, Sahas, what do you mean by momentum? What do you mean by momentum? Sahas, are you there, Sahas?
Sir, I'm not sure.
Bhumika, have you given message so that I can see? Right, Bhumika. Bhumika. Sorry. So when I join through this mobile, you are getting some resound. Okay. So I can't see messages. That's why I checked it. Okay. Arno, tell me momentum.
So the motion contained in a body.
Right. The motion contained in a body, or else give me in a equation form. Equation form means what will be the equation for it and how to define it.
P equals to mv.
Very good. P is equal to mv. That means linear momentum now will be equal to what I have to write here? Mass into velocity. M into V only, no? Mass m into v, velocity. So this is P is equal to. Now we are learning about what? Conservation of momentum, which is a result of Newton's third law of motion. And what is the Newton's third law of motion? For an every action, there will be an equal and opposite reaction. And now let us try to understand about that application by learning what? Conservation of linear momentum. And whenever you are saying conservation, what do you mean by it? Whenever you are saying about conservation, what do you mean by it? Conservation of energy. Just now you only said Arnav. What is conservation of energy? Energy neither be created or nor be destroyed, but it can change from one form of energy to the another form. That means total energy will remain same. And in a same manner to that of conservation of energy, conservation of momentum. That means a momentum of a system will be conserved. That means the momentum of a system will be conserved. That means the momentum for one state of a system and to the other state of a system will remain constant. So you have to say like this, the statement of the conservation of momentum can be given like this. The linear momentum of a system will be remain constant, remain constant, remain constant when no force is acting, no external force is acting on the system. So this is about generally conservation of momentum. So momentum will be conserved. So system, whatever is there, that system momentum, total momentum will remain constant. So we have to understand that in a with some example, then you can understand it in a easy manner. Now here we are taking one system. We are taking one system here, and in that system, how many masses are there? Two masses are there. This is first mass and this is a second mass. And these two masses are having, first one is having m1 mass and second one is having m2 mass. And these two are moving. These two are moving. And without an external force, let us think that these two have collided with each other. And maybe you know that collision means touching with each other. And these are colliding without some external force. They are moving in different velocities and they are touching with each other. And why we are learning about collision? In this collision, we are going to prove that the momentum before and after will remain constant. And in this system, how many masses are there here, Arnav?
Sir, two.
Two masses are there. What are the masses, Sahas? What are the masses here? Sahas.
Sir,
What are the masses? What are the values of them?
sir, M1 and M2.
Very good. M1 and M2. Two masses are there. And let us consider this entire two masses are considered as one system. This is considered as one system. And in this system, two masses are there. And what is our thing which we have to prove? The momentum before collision will be equal to the momentum after collision. That means the total momentum of a system will remain constant when no external force is acting in between them. So that is about statement, and we have to prove it. And in order to prove it, first you have to understand about equation form, and after understanding equation form, we are going to derive it. We are going to derive it by using which one? Newton's third law of motion. And see here. Now what is linear momentum equation? Just now only I wrote here. What is that equation? Mass into velocity. So here observe this equation. M1 U1 is there. What is M1 U1? M1 is a mass of a first object. U1 is a initial velocity of the first object. Try to understand. It is initial velocity of a first object. So M1 U1 will be what now? It is actually known as initial momentum of a first body. So I am writing it as PI1, initial momentum of a first body. M1 U1. And what is M2 U2 then? Arnav, what will be M2 U2?
Initial momentum of second body.
Very good. Initial momentum of a second body. I am writing initial with a I to recognize whether it is first body or second body. So PI1 is a initial momentum of a first body. PI2 means initial momentum of a second body. And what is this M1 U1 plus M2 U2 total? What will
Momentum.
be this total? This will be total initial momentum. That means it is a net initial momentum of a system. This is P1 plus P2. No, here PI1 plus PI2 gives us the net initial momentum of the system. So that's why I'm writing PIN here. So linear momentum in a first case. And what is M1 V1 now? Let us consider, just now only I said how many objects are there here? Two objects are there. Two objects are there, and they are traveling with different velocities and they collided. That means they are touching with each other. And after touching, again what is happening is these two objects are moving. After collision also these two objects are moving, and first object is moving with a velocity v1 after collision, and the second object is moving with a velocity v2. And already you know this is the second mass and this is the first mass. So m1 v1 and m2 v2. So what is m1? Mass of a first object. And what is a v1? Final velocity of the object after collision. Actually collision means some interaction occurred between them, and after interaction they are moving with different velocities again, and v1 is a final velocity of the first object, v2 will be final velocity of the second object. So now try to understand this equation here. Now here what is there? M1 v1 is there. So m1 v1 means what? Mass into velocity of a first object after collision. So that's why what I have to say for this? P final momentum of a first object. Is it right, Arnav? M1 v1 will be final momentum of a first object.
Yes, sir.
How? How it is a final momentum?
Sir, M1 V1 plus M2 V2 will be
Ah,
final.
I'm asking about M1 v1 only, Arnav. How it will be final momentum of a first object? With what you are saying it is a final momentum of a first object? With what you are saying it? Here is there no term. M1 stands for mass, V1 stands for final velocity. As it stands for final velocity, definitely it will be final momentum. So final momentum of a first object. What will be m2 v2? Final momentum of a second object. And what will be m1 v1 plus m2 v2? This will be final momentum of a total system or total net final momentum. So now observe carefully how much initial momentum is there in the system. Same final momentum also will be there in the system. That means for a system, the total momentum will not change. Even collision is occurring between them. So that means just now we learnt for a law of conservation of energy, energy neither be created nor be destroyed, but the total energy will remain constant. How total energy will remain constant? By transferring energy from one form of energy to the another form of energy. And here also same thing will happen. In this system, the momentum, total momentum will remain constant. But what happens is the momentum of first object may be transferred to second object, or momentum of a second object may be transferred to first object. But what happens is total momentum will remain constant. So that is what you have to understand. So the linear momentum of a system which is not applied by an external force will always remain constant. That is about the law of conservation of momentum, and that we are going to prove now. And when we are going to prove it, you have to understand about initial momentum of a first object, final momentum of a first object, initial momentum of a second object, final momentum of a third object, like that. But to derive this equation, you must remember again about Newton's third law of motion.